So let's talk about some periodic table trends. And so the first one we want to focus on is atomic radii. So atomic radii is just going to be the distance from the nucleus of an atom to the outermost electron shell. So if we're going to talk about the trends, usually most of these have some kind of pattern for if they increase, decrease, whatever. So for atomic radii, we increase the radius of an atom as we move down the periodic table. And that should kind of make sense, just because as we move down, we get into larger and larger shells, and those larger shells are going to cause a larger atomic radius. Now, this is usually the trap that you don't want to fall for. Most people would probably say, oh, so when I get more electrons as I move this way, I would increase the atomic radius. But no, just because, let's say I'm talking about sodium here, and sodium has, let's say, 11 protons, 11 positively charged atoms in the center, and let's say this is all the nucleus, and that terrible boulder-shaped ball that I just made. And then here are some of my electron shells. And actually, let's just draw only the most outermost shell. So on that outermost shell, it has one electron right now. Now, I have a positively charged nucleus and one electron on this shell. Now let's see what happens if I go to magnesium. Well, now magnesium has 12 protons, so it's got an even more positive nucleus, but I really don't increase in size much when I actually give another electron. So because there's a more positive center and I don't really increase in size when I put another electron in, I'm actually going to shrink my radius ever so slightly, just because now there's a greater pull on those negative electrons by that more positive nucleus. So my trend is actually going to be downwards and to the left. So for an example, magnesium actually has a smaller atomic radius than sodium. Now, that's about atomic radii. Now let's talk about ionic radii. And so ionic radii are just going to be different ions that we usually consider to have the same charge. So let's say we're going to set this all equal to neon, so with 10 electrons. So we can have neon in its neutral state, fluorine in its -1 state, oxygen in its -2, and then on the other side of the spectrum, if sodium with its 11 electrons loses 1, will also be at 10, then magnesium can lose 2 and also be at 10. So all of these have the same number of electrons. Now, even though they have the same number of electrons, oxygen has a less positive nucleus, just because, it only has 8 protons, while magnesium actually will have 12 protons. So imagine that. How is this trend going to work here? Well, for ions, whichever ion has the largest atomic number, that's actually going to have the smallest radius. Well, while this oxygen has the same number of electrons, right? They all have this filled second shell. This will be the largest radius because those electrons aren't getting pulled in as much by 8 electrons compared to the 12 of magnesium. So make sure you know the difference between the ionic radii and the atomic radii. Next, we have the trend of electronegativity. And so electronegativity is just going to be really about how greedy an atom is with its electrons. And I'll explain that in a second, but the trend is upwards. I can do better than that. Come on, yeah. And to the right. So, what I usually mean by greedy is I'm going to compare nitrogen to oxygen. And so if nitrogen wants to make a new bond, and let's say it has a couple of electrons available, and compare it to oxygen that has a couple of electrons available, and let's say they both want to bond with, let's say, element X. To bond, they have to give up this lone pair to actually make a bond. And so if I'm talking about electronegativity is the greediness of atoms, and I know that this trend is to the right, that means that oxygen is more greedy than nitrogen. So because oxygen is more greedy, it's not going to commit its electrons, it's going to hold them more often, because that's a more stable thing for oxygen to do, while nitrogen, it's less electronegative, which means it's less greedy with its electrons, it's less likely to hold them, it's going to go and commit them to that element. So electronegativity is just basically about how much an atom holds on to its whatever, I'm not a grammar professional here. And then we'll just do ionization energy and the electron affinity after this.